I guess before I begin, I did present some of this content at on Haven's BI YouTube, but I sat down yesterday. I haven't looked at my notes or anything since then. And I sat down. I thought, oh, I better, think about what I'm going to say and go through the session again. And then I thought maybe that sounds pretty boring. I'll do something more interesting and see if I can improve the DAX. So I did that instead. So I haven't prepared very well. I thought I'll just wing it. So we might have to bumble through the presentation a bit together, but I reckon that I'm more excited about the revised code and some additions. So hopefully that'll make up for it if I stumble around. I'll share my screen. So I've just got like an intro slide here. A couple of things about me. I've just joined a new role actually as a fabric lead back in the consulting world. I was in business world as the head of analytics. Worked in lots of different areas. I'm quite passionate about low cost solutions, particularly now with fabric. I'm really into seeing where you can make things more efficient. I do a little bit of presenting on when nice people ask me to, like Sue. People know me for calculation groups in Power BI, but I'm pretty broad because I've been consulting now as a lead consultant for many years. So I'm across lots of different areas. And I'm quite passionate about that, about mentoring other consultants and leadership and those kinds of things. But enough about that. So there's a few slides and then we'll get into the DAX and the demos and all of that kind of stuff. But I thought I'd spend a little bit of time on what's this about? Why is it important? So I think it's just low-hanging fruit, really, for analytics professionals. It's a really easy way to add value to a business because auditing things like timesheets is quite painful and time-consuming, and there's a lot that you can automate using Power BI reporting. And there's always inaccuracies. People are terrible. It's generally something that's manually filled out, so there's always errors. It represents one of the largest costs for business, usually 20 to 30% of revenue. So there's direct kind of impact on bottom line. Anyone that employs casual staff will have some kind of system to track hours or wages. It's quite widespread. You see timesheets in many businesses. Even salary-based employees, if you've ever worked in consulting or in a law, anywhere that has that kind of operating model like consulting, like law firms, you'll have time tracking. So often need to track different tasks at time. Rosters as opposed to timesheets are like a forecast for business, so that they can say, here's a big chunk of cost that your business is going to have. So reporting on those can be useful for forecasting. And I've got a couple of links that I found there. I don't know how reliable they are. They're just some Google searched links that I found, but one of them said that 40% is the percentage of outgoing costs for labor-intensive businesses like hospitality, and even up to 60% for certain logistics companies like trucking businesses. And then just something on time theft, a bit negative, but there is time theft where people try and fudge their timesheets a bit. That can often add around 5% to payroll costs. So lots of businesses struggle with it. So this whole slide is really just saying it's a good thing to report on. It's easy to show some value to a business.
I completely agree. I'm working on something at the moment to do with it, and it's absolutely, it's something that is critical for reporting, but it's always quite complex. There's always but we do it for this people using this system, and then this people using this system. Oh, and I forgot, we've got these ones as well. So this is so practically useful. So I really appreciate you doing this.
Oh, great.
But it's also, Kane, the other thing as well is you also have to, the thing that I think annoys a lot of people about timesheets is why? Why do we have to fill it in? You have to give them the rationale behind doing that. What are you trying to achieve as a business, instead of just saying you have to do it? Well,
Exactly. I couldn't agree more. Yeah, I mean, I have direct experience with it in consulting. It's always, you might be working multiple projects if you work for a consulting firm, and you always have to be like, well, I spent this much time on this one and this much time on this one and this much time in between. And always, every month, it's like, we've got to pay bills now. We've got to pay you. And so we need to invoice our customers. So we need the timesheets done so that we can tell customers, how much they need to pay us so that you can get your pay, so yeah. And it's always, I've seen different people try and deal with it in different ways, and it's always a challenge end of month or end of pay cycle. It's like, you're on the naughty list, you haven't submitted your timesheet. So the first step that I talk about is modeling, and it's a big depends. And there's a certain type of modeling for timesheets that I'm going to cover here, a certain scenario, but there's different ways you could approach it. So first step in building any kind of data model is define the grain of the fact table or the data model. And the first, there's questions that you need to ask, which is, what level of detail is the time stored at? What's it recorded at? What level of detail does it need to be reported on? Because sometimes timesheets will be rounded to 15 minutes or that kind of stuff. How much history are you dealing with? How many timesheets per day are coming in? What are the metrics that matter to the business? All these things are important because it can get very big. If you want to, a recent project I did, time was paid to the minute with timesheets, and minute level accuracy was required, because even if you were just reporting on, say, the number of people on shift, it was quite, high frequency operational reporting, even just the number of people on shift, if you had an hour in the report, they wanted to see that as a fraction. So if somebody knocked off shift, at 1:27, they wanted to see the number of people down to a fraction. So you needed like minute level accuracy in a way.
What did they need it for? Why did they need that level of granularity? Did they actually need it?
Good question. I guess they were honing in really hard on wage cost percentage per hour down to like a half an hour, because it was really critical to their business. So they were really looking at fine-tuning it, so they wanted to see, how much they were paying and how many people they had on, and where, if sales dropped at a certain point, were people getting knocked off and all of that kind of stuff. So maybe a little bit overkill, but the request was, I want to see not just in that hour, I don't want to just see that there was 3 people on. When somebody finished at 27 minutes into the hour, I want to see that there was 2-point-something people on, which makes sense to me. Perhaps not down to the minute level in the reports, no, down to this kind of 30-minute and hour level in the reports, but the minute level was required for the level of precision sometimes. So if you're recording, if you were defining a fact table, and you wanted that level of accuracy, you would define it by every minute of the day. Like you can see down here, you'd have all of your minutes, and then for every minute you'd have every employee, and then you'd probably have flags for every employee saying on shift, active, on break, all of that kind of stuff. But that's not what I'm going to go through here, because if it's not usually in that format in any of the systems that you normally work with. Normally timesheets are, here's a row for a timesheet, here's a start time and an end time, and it might have a break start and a break end. It doesn't usually thing like this. And there's a but here, but this can make certain types of calculations easier, because you can filter by the time column and you can just aggregate things, and it's a lot simpler for certain things. But there's a big but, which is it's not always practical. There's a lot of considerations. Like I said, you need to ask a lot of questions about what you need to do. But even if you have a modest 500 employees in a company, which is a medium-sized company with 5 years of timesheets, you're looking at kind of 1.3 billion rows for a table that goes down to, 1 minute detail level. Even if you went to a 15-minute grain because, you wanted to round everything, it's still, quite a lot of rows in a table and a big table. if you go up to a big company, 10,000 employees, it just gets kind of unmanageable. And I said before, I'm quite passionate about low cost and efficient solutions. If you're not starting with your data in that format, you know, getting it into that format using Fabric or whatever tools you're using could have quite a cost associated with it. You know, you're not just, it's not just doing like a cross join kind of thing. There's different metrics that, you know, need to be included. So you might have aggregations and things like that, or you might have to split out numbers. It's not a simple way. It's simple to just take a list of timesheets with start and end times and then split it out into a 1.3 billion row table of timesheet status by the minute. So not practical sometimes. I mentioned there's all these questions that you need to consider first, but yeah, there's a cost element, and then what about breaks? There's a lot of considerations. So there is a case for, oh, sorry, this is the case for why you would split it out by the time grain. If you don't mind, no, sorry, I told you I hadn't prepared my presentation. This is why you would choose not to do that, I believe. So if you don't mind getting your hands dirty with some DAX for the time-based calculations, which I'll show you, and you want a solution that's lightweight, fast, and maybe more cost-effective, then this grain can be a good choice by timesheet. So if you do it by timesheet and date, so every timesheet by every time, I think this should say time, you know, you can be easier for some time-based calculations, splitting everything out by time. But if you just want to keep it at all your days and all your timesheets, you get smaller table size, can be easier to ingest and do that ETL stuff, can be better on cost because you're not having to transform it as much. Performance, date-based calculations are still easy because you're at date level, you haven't gone down to time level. You get a better kind of, can keep more history perhaps. Can cover a large number of employees easier. And if you wanted to do this in Power Query only, like if you were with a smaller company and you were just doing a Power BI only solution, it might be, you know, Power Query probably might not be the best choice to try and handle splitting out a table into tons and tons of rows. So what we're going to look at today is reporting when you have rosters or timesheets in a fact table that's one row per timesheet per day, and the challenges with that, and then sort of how you get around it with DAX. So one of the key things to keep in mind when we start looking at this, because it is complex, I'll do my best to explain it simply, but the important thing to keep in mind is that this is a timesheet table, is that, you know, timesheets can have two dates, a start date and an end date, and two times, a start time and an end time. And generally, you have one active relationship on those. So it's usually the start time. You have time connected to the start time and date connected to the start date. Why this is important is because it's just important to keep in mind that if you were filtering by time in a report, it means that you're just getting the start times of the timesheets. It'll make more sense as we go, but keep that in mind. We're filtering by time and it's by the start time. So if we filter to 1 p.m, we're only getting timesheets that start at 1 p.m. So a couple of tips here as well before we get into it for dealing with timesheets. So one is businesses operate different hours. Sometimes shift-based work can be overnight. It can be all different things. So it's good to define the start and end of a day. Because you can have shifts that run over 2 dates. You can have shifts that that end after midnight. And when you're trying to run calculations and look at, you know, something being less than something or more than something, you know, midnight's tricky because after midnight things reset, and, you know, across 2 dates it can be things. So first thing is, when does the day start and when does the day end? Just make sure you've got that well defined. By business hours, not clock hours. Offset dates based on day start and day end. So if a shift runs over 2 dates, most often it will need to be reported as one date. So you can usually just add a column to your fact table to say, if the time is, greater than a certain time and less than or equal to the end of day, then minus off a date. You just sort of offset it and say, if it's after midnight and it's the next day, but it's part of the same shift, we want to treat it as the same date. So you just shift all your dates to make that possible. That's one trick. If possible, add a start time and end time number based on the time. So this is something I've done. It makes debugging and calculations easier. You can just minus times off each other, but it allows you to be more explicit and custom with things like sort orders, and it's easier to debug a number minus a number than a time minus a time. If you look at like an AM PM time and another AM PM time and start doing calculations, it gets confusing. So think about if you need to calculate the duration between 11 p.m. and 2 a.m. It's 3 hours, not 21 hours, right? So that's an example. 2 a.m. to 11 p.m. is 21 hours, but 11 p.m. to 2 a.m. is 3 hours. So this is why it's better to just get rid of times and start working with numbers. Makes things easy, like additions and subtractions. Understand the business processes and the source system. So some systems log, I think we touched on this too, some systems log timesheets automatically as they happen. Others are manually entered after the event. Are there always end times? What sort of flags and filters are there? What's the approval process? What about breaks? Because like you said, Sue, just getting people to fill these out can be a thing. So you need to know, what do you do if there's missing entries? What do you do if it's got no start time, no end time? Some systems that I've worked with, the person logs in and it starts the timesheet, and then if they haven't logged out, it means that's in progress, and you can report on that. It's a timesheet that's actually happening. So there's all these, and there's always business logic that needs to be added in there, special filters and different things to say, it needs to have this certain tick of approval or this, whatever it might be. So those are my tips to set yourself off on the right foot before you start reporting. Just make sure you've got some of those things worked out. All right, I'm almost done with the boring slides. We can get into the Power BI and the DAX, but this is kind of the scenario that we're looking at with timesheets. So these are the things that we'll try and solve using DAX. So this is a representation of what timesheets might look like. You've got times, and they're events in progress, essentially. They span different times. There's a really good SQL BI DAX pattern called Events in Progress, which you can check out. But that only does things by date. It looks at like orders spanning a number of dates. So it's a little bit different when you get into times, which is why I thought, this is a worthwhile session rather than just pointing people at that article. But it's definitely worth checking out that article. It's a similar concepts. So the questions to think about here are, how do we approach this if we need to count the number of staff on shift between 1 and 2 p.m, if we need to calculate the number of minutes between 1 and 2 p.m, and we need to calculate the cost between 1 and 2 p.m. Those are kind of standard questions that a business would ask. If you look at between 1 and 2 p.m, there's all different scenarios here. There's timesheets that start and begin. I mean, this probably wouldn't happen, but for the sake of the example, a timesheet that begins and ends within this time window, one that starts way before it and ends in it, one that starts in it, ends after it, one that just spans the whole way. Why this is tricky is, when you remember when we spoke about it before with the data model, our time dimension is connected to the start time of the shift or the event or the timesheet. So when we have a filter, a point of filter context on a chart like 1 p.m, we can't just say count rows of the timesheet, say, because it's not going to give us. If we wanted to say, well, how many timesheets are here? There's 4. If we did count rows of timesheets at 1 p.m, we're going to get none, because none of them start at 1 p.m, right? So this is the challenge. And I guess this whole kind of exercise and looking at the DAX is a really good refresher on kind of filter context and thinking about filter context. So one thing that I'll point out is if this was a chart in Power BI and we have these points on the axis and we're thinking about filter context, really when we have 1 p.m., what it's representing is 1 p.m. to 1:59 p.m. It's like 1 hour and 59 minutes and 59 microseconds and nanoseconds if you wanted to think about it, but it's not 2. It's just saying that when we say 1 p.m., we're actually talking about everything that fits from 1 p.m. all the way up to 2 p.m., but not including 2 p.m. And 2 p.m. is everything up to 3 p.m., but not 3 p.m. That's what would be present in anything filtered. How am I going to explain this? So you have hours on your chart, but in your timesheets, you have all different times. It's connected to your time dimension is connected on like a minute level. So it gets all the times, but when you put an hour on your chart, it's still filtering all the times that fit within here. Yeah.
Anything that helps me and refreshes me and keeps me fresh with DAX is always good, Kane. Always good.
I'm going to do my, sometimes I get, I trip myself up trying to explain it in a good way, but I'll do my best.
We'll ask questions. So anyway, we're all here to learn.
Yes.
And we like
it.
Yeah,
interrupt me anytime. Tell me I'm not explaining it well.
No, we will.
All right.
Don't worry.
Okay. So this is what we're going to look at. How do we do this? Let me find some notes so that I can, let me see what's on the next page. Should I go here? No, this is where we start looking at DAX. Okay. So let's tackle these one by one. Let's look at the number of staff on shift between 1 and 2 p.m. And I'll bring over some DAX to have a look at. Got some, is this the right one? Yes. All right. Quite simple to start with. Number of people on shift. This source system's called Deputy Timesheets. There's a system in Australia for managing timesheets called Deputy. This late night time is my time dimension. I've called it late night time because it's got a custom sort in it to account for late nights where it runs from 2 p.m. to 2 a.m. Sorry, and this late hour sort is like a numerical representation of the time. And so this is quite similar to what you find in the SQL BI article where we can just sort of count our timesheets. But the problem is, should be this actually, the problem with it is that, like I said, if we go back to our diagram, we can't just count the timesheets because everything's filtered by 1 p.m. and none of these really, these don't start at 1 p.m. These start in here, so you probably get those two if you did like a count rows. So we've got our count rows, but we basically, a lot of these calculations, you need to remove all the filters from the time axis and then kind of manually replace them in a way. So we've got our remove filters here on time, which says ignore all that, ignore the relationships, just count all the timesheets. But then we manually put these filters in place to make sure that we get the right ones. So it says if the end time of the timesheet is bigger or equal to the minimum time in the chart, which is here, or less than the max time in the chart, then count it, essentially. Count it with these filters. And that is either it ended after or equal to the minimum time, which would be 1 p.m, or it started sometime before 1:59 p.m. So that's the first example of simple calculation. Now it gets a bit more complex. So what if we need to do the minutes? We want to count the minutes only between these two times, because at the end of the day, what we want is a chart where we have times on the axis like this, but we want a bar chart that just has minutes as we go through the time. So we need to count, in this case, we need to count the minutes from the start to the end, because it ends after, but we only want to get this one that scans the whole filter context. So this would be 60 minutes here. This would probably be like 45 minutes. This would be 15, and this would probably be 30 here. So that's what we need to count up somehow.
Just saying, I like the way you explained the remove filters part. I think that was probably the best explanation I've heard for remove filters at the end.
Thank you. Excellent. All right, let's step through this more complex kind of example. It looks like a lot of code, and it probably is, but it's not as bad as it looks. So let's step through it. What we're doing is we're defining our boundaries first. We've got our minimum time and our maximum time. So in our example of 1 till 2, that would be minimum time would be 1. The maximum time present in the filter context would be 1:59. Yeah. So we define where the boundaries are. This timesheet table, this is to do to be more efficient rather than just grabbing the whole timesheet table. What I'm doing is just grabbing the timesheet table and just grabbing the fields that we need currently. We don't actually need all these. I don't think this one's in there because I used the same sort of calculation with cost. I've probably done some copy pasting, but the idea is just get the fields that you need to do this calculation rather than the whole table. So I've said summarize the timesheets table by the things that I need, making sure that it's at the right level of detail because I've got the ID in there. And then I've got the remove filters on time for that reason that we discussed, because we don't want that start time relationship to be affecting things. We're going to be more explicit about how we count things. It's still good to have the relationship in the model because we might need to calculate things in different ways, and it's always better to leverage a relationship if you can. But for this, we will remove all the filters on time and just say, give us all of the timesheets unfiltered by time. So then what we're going to do is we're going to go through every timesheet. This is our iterator here, SumX. Go through every timesheet that's there and find out where the timesheet ends, find out where the timesheet starts. And then what we're doing here with the end number and the start number, we're finding which one is smaller, the end number or the maximum time, the end of the timesheet. So we're saying, this is useful for these ones, right, where it spans the whole thing. We're saying we need to find the boundaries. Is it going to be the start of the timesheet or the start of the filter context, or the end of the timesheet or the end of the filter context? So we're using, if you use min and max with 2 parameters like we have here, it'll give you which one is smaller. So we're saying what's smaller? Is it the timesheet end that comes first or the end of the filter context? And then we're doing the same for the start. We're saying, is the start, what's higher? Is it the start of the timesheet, or is it the start of the filter context? And so we're just saying which point should we use, because if the event starts after 1 o'clock, then we need the timesheet start number. So we need the timesheet start number is going to be bigger, and so we use that. But if it starts before the filter context, we still want to count it. We need to start it from the start of the filter context, from 1 p.m. The next line is a check to say we don't need to do the calculation for every timesheet, because what if the timesheet ends after the filter context that we're in, or the timesheet starts way before, then we don't need to count it. So it's basically saying, don't bother with this one over here. We don't need that. The only ones we need to count are these ones. So if it ends before the start of the filter context, or it starts after the filter context, don't worry about it. It's not a valid timesheet. We don't want to count those. So that's what this does. It just says this is true if the timesheet is valid. So it's saying the timesheet has to end after the start of our filter context, and it has to start before the end of our filter context in some way. And then we just go, well, if it's a valid timesheet, take the end number, or minus the start number from the end number. And that gives us the amount of minutes in the timesheet. So there's one other thing, which is this +1 here. You might think, why is there a +1 on the end number? And that's because, like we said, we have 1 o'clock, and then the end of 1 o'clock's filter context on the axis is 1:59, not 2 o'clock. But if something spans that entire part there from 1 till 2, we want to count it as 60 minutes. But if we say that the end is 1:59 and the start is 1, and we do the minus the minutes away from each other, we'll end up with 59, right? So we need to add on 1 to make sure that we get 60 minutes for that. So it's kind of confusing when you first look at it, but in essence, all we're doing is looking at one point of filter context, which is always useful for writing DAX, right? Rather than looking at a whole chart and being like, how is this all going to work? We're just looking at one point on the chart, saying when we've got a filter on 1 p.m., how do we count these? The way that we do it is remove all the filters on time, and then explicitly put a conditions in that say, well, we want to count things that fit our conditions. They start before the start of the filter context. They end, they don't start. This is where I get confused. Explaining the conditions is the hardest part, but I think you get what I mean. We're just looking at these and saying, how can we capture these? Now, this code is improved from when I did the Haven stuff. I actually had the conditions a lot more listed explicitly. So this was the code that I presented there. It's actually more confusing and complex, has all these comments, and this is me trying to, explicitly list every possible condition that we need to count. Well, if these are the ones that are blank, that are covered by that, valid timesheet line now, and these are, timesheets that cover all the times in the filter context. These are ones that start and finish within the filter context. These are ones that start, and I've gone through and tried to cover every single scenario that you can see here. But then this is the improved version, which I was more excited about, where it's a lot simpler, where we just, and then this line,
simple DAX is much better, Kane.
Yes, I mean, this DAX is already too complex, I think, because it has to be, because we haven't gone with that original define the grain down to the grain that we want to report on, right? If we wanted to report at the minute level, we need a minute grain fact table. We haven't done that. We've said keep it at date level, so we're kind of allocating across minutes now, and that's where the complexity comes from. But it's efficient, particularly because when you report on timesheets, you're often looking at specific days or small amounts of dates, and it seems to perform quite well, these calculations. I've found them to be quite fast. So like I said, if you're going for low cost and simple solution and you don't want to do all this transformation, this can be still quite an efficient, fast, cost-effective, good option. This part here...
someone in the chat's just said, can you zoom in a little bit if possible?
Yes, my bad. Sorry.
And what I do, BA, I can't see the name from that, is I get it to pop out of the Teams. If you get it to pop out so that you have the speaker and the chat, if you've got two screens, then I have a full screen with the shared screen on it, and that makes it easier to see as well.
What do I need to do? Sorry.
Just so could you zoom in a bit? But I think you've zoomed in a bit there already.
Yeah, I've zoomed in a bit now, and I've got the screen on.
There we go.
200%, I think so.
Yeah, perfect.
Just noticed this is supposed to be. This is called. So I've done a bit of copy pasting of code, but I'll just fix it really quick.
Showcasing Tabular Editor as well. They'll be pleased.
Yeah.
It's so good, though, isn't it?
It is. It's the best. Okay, this is better. So this last line is just saying when you're not looking at time, because you always got to think how these calculations might be used in different contexts. This kind of scenario where you're calculating the minutes based on start time and end times, it's not necessary if you're reporting by date. So this is just saying these are my common time fields that are usually used in charts. And it's just saying if these are in use, 30-minute, 60-minute time brackets, then do this calculation. Otherwise, we can just take, sum the times from the timesheets. And I guess this showcases how simple it is when you've got things at the right grain. If you're only reporting at date grain, it's a simple sum. And I guess if you wanted to expand things out to the minute level grain, you could probably get some simple aggregations instead of doing some of the gymnastics like this, but probably wouldn't be as fun. All right, let's go back to our questions and we'll sort of build up. So we've counted the number of staff. That was a simpler one. We've now looked at the minutes in here, which was a bit trickier. And now we'll look at the cost, which is a similar calculation, but slightly different. Before I do that, I'll talk quickly about another calculation, which is with breaks. So in this scenario, there's no breaks accounted for. Lots of timesheets have some start and end times for breaks. What I found with this particular project was that the breaks weren't reliable in terms of start time and end time. They'd just be put in at the same times every day, but they'd happen at different times. But they did have a reliable amount of minutes. So rather than we couldn't say that the break happened at a certain time. So we had to allocate the break minutes across the entire spectrum, if that makes sense. Might make sense when we look at the code. So this is the same sort of code, but there's a few extra things that I've added in just to sort of ramp up the complexity. It's the same idea where we define the brackets of the filter context, the max and min time number. We create our table for efficiency that only has the columns we want. We remove all the filters on time because we don't want them to start messing up our calculations. And then we start iterating our table, going through each timesheet line by line. So for this one, for the end number, put in a condition that says if it's greater than 60, make it 1441. Otherwise, just keep the same number. The reason for that is, again, some of these strange, as I said at the start, you need to understand the business rules and logic and things like that. The reason for this is that the day in this case ends at 2 a.m. But oftentimes, people work past that cleaning up or closing up shop. So the numbers run all the minutes of the day until 1441. From 1 to 1441, there's 1440 minutes in the day if you started at 0, but 1 to 1441. 1441 is 2 a.m. So what it's saying is if it's less than 60, because the day starts at 2 a.m., 1441 is 1:59, because the day starts at 2 a.m., that's 1, we'll give them an hour. We'll say if it's in the first hour of the day, which is 2 a.m. to 3 a.m., just make it the end of the day, because we still want to count those shifts. Because what happened is obviously we put all these calculations in place and there's some shifts missing. And it's because people are still working after 2 a.m. because they're cleaning up or whatever it is. So this is just adjust that. We've got our start of the shift number. And then again, we check which comes first. Is it the timesheet end? What happens first? Does the timesheet end or do we hit the end of the filter context? We add our 1 to make sure that when we do our subtraction, we get the right number. And then our start time, what happens first? Does the timesheet start? What happens last? Does the timesheet start or is it the start of the filter context, which is higher? What are our valid timesheets? And then our calculation of the minutes. And then our total minutes for the timesheet. And then our break minutes, we divide the complete break duration for that timesheet by the total shifts in the minute to get a per minute break amount, and then times it by the amount of minutes in the filter context. So quite a lot of a mouthful there. But what it's doing is just saying, well, we've got a break duration, so let's take that break duration and we know how many hours this person was, how many minutes this person was working. That's this total time. So we say they were working for 120 minutes, 2 hours, and they had a 30-minute break. So we take that 30-minute break, split it out across their entire time, and we know that's, this much break per minute that they had, and then we times it by our minutes, and that gives us like an adjusted overall time that's had a slight reduction across the board by the breaks. And then again, we just return if it's the valid timesheet, we'd get our minutes that we're counting and we minus off the break minutes that we've calculated. And then we do our same check again say if time's filtered, do this calculation, otherwise do our simple calculation, and then otherwise this should be here a different sum, but you get the idea. So that's sort of incorporating breaks and allocating them across the entire shift, because you don't have reliable start and end times. Last one to look at is cost, and then we'll look at some, we'll get out of the mine melting kind of DAX and jump into some reports and some examples of how to use it. So the last one is cost. Same principle again. I won't go through it all, but we go through our timesheets. We do everything that we did before. We define the boundaries. We figure out how many minutes exist in that filter context point. We find out the break minutes and we adjust for the break minutes like we did in the last one. And then we do the same with the cost. We take the cost, the total cost for the timesheet, we divide it by the total amount of minutes in the timesheet so that we get a per minute cost. Once we have a per minute cost, we can just take our total minutes and times it by the per minute cost. So the approach, if we look back at our diagram, is we know how to figure out now the amount of minutes for 1 p.m. and then we take the total for a timesheet. So say this timesheet's 2 hours and 15 minutes. We take the cost for that timesheet, divide it by the 2 hours and 15 minutes to get our per minute cost, and then we multiply it by the amount of minutes in the filter context to give us the portion of cost that fits in here. And then we do that because we're in an iteration with some X here. We do that for each timesheet. So that's all the complexity. That's as far as it goes. I know it's it took me a long time to get my head around it, so I'm sure that just explaining it in 10 minutes is also tricky. I guess any questions or any confusion there? Does anyone want me to run through something a bit differently?
Yeah, it makes sense. I don't know that I could do it. I would have to need your PBIX to look through and work through it point by point.
Yeah,
but it does make sense.
Yeah. So what I've done, which might be simpler than looking at all the kind of, system specific fields and all of this kind of stuff, is I thought about it and I was like, well, there's a lot of custom logic getting reused here. We're calculating minutes and costs, and it's the same calculation for timesheets and rosters and different things. So it makes sense to do like a DAX function. So I did one here. I did a nice time to number DAX function, which you can feed in like a start time and it will convert it to that number for you if you don't have that kind of in your ETL stuff. And it has an offset too, so you can add an offset. So you can say, start the day at 2 a.m. like I did.
Yeah.
So this does that. And then for the shift minutes, full disclosure, I used an LLM to help me comment the code. It basically does, you can input all the columns that you need. So you're at the table where your events are happening, your time table, your time column. How do you identify each event, the start time and the end time? And it will convert your filter context boundaries to a time number. So your minimum time and maximum time in your filter context. It'll calculate that event table for you using only the columns required and removing the filters on time, like we said, so that you can do your calculations. And then to get the minutes, this is the exact same calculation we looked at, but maybe in simpler terms because there's no system kind of language in there. But iterate your time sheets, grab the start of the timesheet and the end of the timesheet, and then make any adjustments to your end number if you need to. This is I wouldn't keep this in the, if I publish this, but this was that thing where we spoke about if it's that. And then the find which comes first. Does the event end number come first, or does the end of the filter context come first? So does it end within our filter context, or does it go all the way past it? Does it start within our filter context, or does it start before it? So what do we need to use as the window bounds? And then what are our valid events that we want to count? And then if it's a valid event, just do our simple subtraction for the minutes. And then I've got one that expands it out a bit too and does with the break allocation, which is kind of more of a niche case, I guess. And then one with the cost too, where you can. So I replaced in the project all of the calculations which I showed you with ones using the functions, because it wasn't just timesheets, it was rosters and many different things. So this is, the code becomes much simplified. So this would be the cost code. Still got my check to see if we need to use it by time, but you can just, use your function with shift cost. And this was just, the minutes can be quite, that was a head count. The minutes, you get the idea. So you can simplify the code quite a bit. And I guess I might look at publishing this minutes one to the UDF library. See if anyone else finds it useful. I can't share the PBIX because this was from an actual project and they were generous enough to let me present, and I've got some reports to show which I've randomized, but I can probably publish the function instead.
Yeah.
All right.
And if anyone needs it, then they can pause the video and write the DAX themselves.
Exactly. Yeah, you can pause and take a screenshot. I communicated with someone who did that from when I presented some of the content on Havens. They found a mistake in the code and messaged me about it on LinkedIn. And
that's how we all get better, though, isn't it?
Oh, look, I think mistakes are the best thing in the world. I think you're not learning unless you're making mistakes. So I'm always happy when people prove me wrong. If anyone can do the same for this presentation, I'd be really obliged. I love getting proved wrong. All right, let's have a look at some reports. So just some examples. Try and finish on a lighter note of some things that you can do if you do take the time and do some of this stuff with timesheets and rosters. Just some examples of some reporting. I'll show the reporting first before we do my sort of final slide. Where am I? What am I doing? Reports. I've got it in my workspace here, I think. Let's have a look at this one. Maybe I'll do full screen.
We've got Aurora doing a drum roll in the chat.
So these are some simple reports that you could build. They've been randomized, so I'll prove it. I'll do a refresh here. So I've used a calculation group to randomize the numbers. So if I hit refresh the visuals, you'll see they take some time, but they all randomize. But the reason that they're a bit slow to load some of the pages is because there's a calculation group over the whole page randomizing every measure. So they're not real numbers. You can't go and find this company and say, I saw your reports in a user group and you look like you're doing bad.
So you weren't paying attention.
So this is like some of the use cases that some companies found useful is, being able to look at a shift time. So like a day or a night, for example, and being able to look at their wage percentage of revenue. So seeing that at a particular time they were using a lot of wages for the amount of money that they were earning. Where my legend's gone for this dotted line, but anyway, I think this is
it's at the bottom, revenue.
Oh, here it is. Yeah, sorry. This is the wage percentage and the revenue. So you can see there's like high revenue here, low wage percentage, low revenue here, high wage percentage. Kind of makes sense.
Yeah.
And then, just looking at the relationship between your timesheet cost and your revenue over time. So you can say timesheets were costing a lot here and revenue wasn't. And they quite found use in kind of aligning the curves that, the revenue curve for them over time was usually quite consistent. If you looked at an average back over previous weeks, you could find quite a general curve that was consistent. So they always wanted to see, is the curve of our timesheet cost matching our revenue curve, or should it be, all these types of questions with various, filters and then some hot totals at the top of, how are we tracking for this particular day on a Friday? What was our overall percentage? Was it up or down? Was it good? And then they could delve into it and say, well, why was it down and good? Was it because we did better compared to another day? or
yeah.
Because these were quite operational. They had needed to be able to see at a particular time if things were not going as expected, they could reduce the amount of staff on shift.
Yeah. I mean, that's the critical thing, isn't it? Trying to understand when you need people,
yes.
Whether it's manufacturing or the service sector.
Yeah.
Oh, I like that.
So this is more of like a kind of looking at some gross profit minus wages. So looking at where did we make good money basically. We did pretty well at 8 p.m. and where did our wage cost rise above our other costs? So you can see here cost of goods was the lowest and the wage cost was highest, but then here wage cost was low and cost of goods was high. So just looking at the relationship between those things over time and seeing for a particular day, and then there's more reporting obviously that you can drill into to try and answer these questions. Why was on this day at a particular time was our cost of goods higher than both our wage cost and profit, and these types of things. So I've got one more report to show as well, another example.
Got a question about your calendar table, but I'll let you do this next one and then we can talk about the calendar table. That's okay.
Sure.
Yeah.
What's the other one I've got here? So I'm just showing these because I think it can I'm hoping it will inspire people to delve into the timesheet reporting, because you can see that there is quite good value, I think, for businesses. There's useful things that you can see. So this one's quite a no-frills kind of operational report that I've randomized again and removed the names from and everything, randomized all the start and end times. But it's a timesheet audit. So it's a very classic business use case that before payroll runs, you need to audit timesheets and ensure that there's no issues. Yeah. So what this does is it has a bunch of rules coded, not in DAX, I think this is in the ETL side, but it looks at all the start and end times and break time and says, is there an issue potentially with this shift? Like, was the break time too long? Was the shift too long? These are the conditions over here. You can have, the employee had a comment against it. There was a long break. There was too short a break. The shift was too long. There was a long shift and there was no break, or it's a very short shift. So these are all the flags that we've set up. So you can filter to those and then automatically flag them with the potential issue. And then it's got a user-defined function in the background for commentary. So you can have a preset comment again. You can select a field, or you can select multiple fields and select a comment. This was fixed, or this was, this was a long shift that was approved, and then you hit comment and it writes it to a SQL DB and brings it back into the report. And it's all got a paper trail in the SQL DB then, so that at any point in the future, if there's any issues around payroll or time shifts, you can come back here and say, well, yes, this was correct. A manager approved it. Here's the paper trail. So a pretty easy report to put together. It's just one big table basically, and it's got, obviously you have to do the write back with the user-defined function in Fabric, but you're just another example of like a time saver for businesses where you can just take some of the pain out of auditing timesheets. So
how did you find that to work out? Did you find that quite easy to do?
I found it reasonably easy to do. I used a bit of help from Claude, I think, to get the DAX, the user data function working correctly. What I found is that the user data function's a bit buggy. I found that there can be issues with deployment. When you deploy it, like they can stop working and invoking them. And I searched the internet a bit and I saw that other people have had problems too with that kind of thing. So I think they're still a little bit flaky. Yeah. But generally being able to maintain it and keep it working for the business. I think they'll just improve, obviously, then, as time goes on.
Yeah. I mean, it's just such a fabulous It's the next step, really. It's the so what, isn't it? So you can see the fact that someone's had a long break, but they might have had a long break because they were doing something which you knew about. So you can approve it instead of having to go into another software system.
Exactly, yeah. So they just do that before payroll. They just have all their managers jump in. They just comment everything. And what it does too is if they don't just comment everything, if there's something that isn't right, they'll go in the source system and fix it. So if there is something that actually needs to be changed because it's incorrect, they'll fix it in the source system and then comment that in the report. And they do all that. They can do that through the week while they're working if they want, or they can just do it all before payroll, which is usually what happens. But it's taken a lot of time out of back and forth and auditing and stuff. They just do that and then payroll runs and they know everything's, ready to go. Did we want to look at the calendar question before I?
Yeah. So Aurora said, "Can you just share?" Yeah. She just asked how you could share about the calendar table and if it had to include a time-hour column. You've got two, haven't you? You had the date one and then you had a time one.
Yeah.
Or which did you use for this one?
This is like just a BIM file that I saved that's a bit out of date too and old, but let's have a look at what I've got. So yeah, I've got a date table, which looks like this. I don't know if this is helpful, but let me see if I can find. What was the question? Sorry, let me find it.
Can you share how the calendar table was used and does it include a time/hour column?
So the date table does not. Date table is a straight date table, although it's a 445 calendar with both 445 and Gregorian. And full disclosure, I haven't set it up with the new calendar functions, which I think you probably talk about next week. I need to do that still.
Yeah, we got Jay on next week to go through it with us.
I guess the only thing sort of more interesting about the I'll drop this down a bit. Can I resize this? About the.
Or you could pop it out, can't you?
Can I? Yeah, I forget how to do that, like that, something. Yeah. So the only useful, the only interesting thing I think here is it's a pretty standard date table, but there's two timetables. One is just the regular timetable that I created that has 24-hour time, regular time, and then different time brackets that you can look at, 30 and 60 and 15 and 10. With this one, there's a calculated table in there for late night time. And I use a calculated table because, I don't know, it's always a point that I think is interesting is if you directly reference another table. So I can't bring it back up now, but the code for this calculated table is just late night time equals time, basically. And if you do that, Power BI is smart enough not to create another table, essentially. It just acts as like a reference layer. You don't get any performance degradation or anything like that. So you can feel free to, it doesn't take long to refresh and all those things about how you shouldn't use calculated tables. Referencing another table is fine. And the reason that I did this one is because it has it sorts to that 2 a.m. So it goes day starts at 2 a.m. basically in that table, and all the sorting and everything's set up to do that better.
Yeah.
And then so there's two key date things and time things in place in the solution. One is the custom sorting of the timetable to go from 2 a.m. Because that's when the day ends. And then the other one is the date offsets, where because shifts run over 2 days, because they go past midnight, it offsets the dates in the fact tables. So that if the date is the next day, but the time is before 2 a.m., just treat it as the same date. So it offsets all those dates that are
that makes
from
sense.
12 a.m. to 2 a.m. to be the next day, so that when you report on one day, it's still
going to the next up to 2 a.m.
Yes, yeah. So that's the setup there. Just go back. Anyway. So yeah, I just had a couple, just to summarize, I guess, to wrap it up, some of the value propositions for why it's cool, I guess, rosters and schedules and timesheets, and some of the things I've experimented with. So cross-referencing rosters against historical performance. because that's a planning thing. You build your roster is like, this is how many people we think we'll need. How do we know if that's the right amount? Well, we can look at history and see all those sorts of metrics like I showed you, like wage percentage of costs and things in the past, and say, you know what, our roster looks like it's, and you can have a revenue forecast too and say our roster looks good, it doesn't look good, looks like we've got too many people on here, not enough there. Looking at future, basically what I just said, looking at the future costs. So planning and forecasting is great. That sort of real-time wage control, so operational type reporting, shift work and that kind of stuff. We have people on a floor or in trucks or whatever, and you need to look in real time, how our wage costs are, so that you can knock people off and tell them to finish, or get more people in, get on the phone and get more people happening. Identify issues by looking at your wage percentage and saying, we've been doing things wrong in the past. That timesheet auditing to catch errors and time theft and issues before payroll, and then ensuring compliance with business processes too. So a lot of times there's like, this is how you should clock on, this is how you should clock off. There's a lot of that stuff which I won't go into, but you can catch when people are doing the wrong thing. So a few thoughts, and that's it pretty much. That's my presentation on roster and timesheet reporting.
Brilliant.
So thanks everyone for listening.
Yeah, so practical. Antony's mentioned about, and for me, I was going to say about sickness, whether you can use it, for people that aren't there, because one of the things I'm working on for someone at the moment is looking at how much they produce, and then the amount of people that are actually on the production site to work out production costs per person to get an idea. And then of course you need to track who doesn't turn up, or who's off sick, or who you're not paying. And then with Antony, it's mentioned about holidays and weekends as well. And then different reporting systems calculate overtime at different. It's a minefield, isn't it?
It is a minefield, but I think it's similar to breaks, right? We looked at some breaks there. It's the same. Like if you're tracking leave and you have a leave table of some kind, then you'll have start times or start dates and end dates for leave, or start times and end times for breaks. It's a similar kind of thing. You just need to either incorporate it into your calculations or allocate it across things like we did. And I think overtime I've dealt with as well in this project in terms of cost. So, you can have another table that tracks, it just depends on the model, obviously. But all of those things, it is, what I showed, is quite specific to this use case, but I think some of the concepts are transferable, particularly like the main thing for me is common is counting how many people there at a given time, and how many minutes of time is at a given point. From the minutes and the amount of people, you can usually figure out like a wage cost. You can minus off things, you can jiggle around with it.
It's that productivity, isn't it? If I've got this many people, regardless of what sector, how much, because staffing is usually such a significant cost. How much am I getting in return for the amount that I'm paying? The other thing I've had to look at for someone else is looking at targets. So they'll have a target for so many hours they need to achieve over a year, and the production or what they need to achieve with those hours. And then of course you have holidays. If they haven't taken their holidays, then, and they're up to, they're on track, they're going to be out for 4 weeks. So you need to then account for, how many holidays have been taken, or how many are due to be taken, and what impact that has upon the forecasted, KPIs they need to achieve.
I have to say it's some of the more challenging Power BI work, I think, all of these sorts of scenarios. It's far from your regular just sales, sum a few columns and add a few filters, it really makes you put your thinking cap on a bit, doesn't it?
And then also, it's like you said, you have one thing for direct employed staff, and then there'll be another system for temporary staff or agency staff. And I do find, I think it's one of the most challenges areas. So when I saw you did this with Reed, I thought, yes, please, Kane.
Yeah, I think another use case that I've seen with it too is staff performance as well. Because if you have metrics like you said, production or amount of items sold or things like that, you can, and then you have timesheets and you can allocate it like we did across time. You can see, well, at between 1 and 2 o'clock we sold 15 meals or something, and we had this person was covering that area, and you can start working out metrics like number of products per minute and for certain employees, and see performance metrics and all that kind of stuff.
And then, definitely. And then the other one that I've had is, as more and more people are working from home, is, what's the productivity compared to working from home as opposed to working in the office? How many phone calls are answered or not answered, or minutes logged for working? And so it's really interesting, isn't it? And challenging. So a huge thank you. There's been lots of comments. I think we're up to about 20 odd in the session. Lots of discussions in the chat. So I think it's one of these things. So Takimi said performance matrix, experience level and performance result. Oh, that's going into a whole new zone, Takimi. Yeah, thank you for a great session.
I'm glad people found it interesting and useful. So appreciate it. Thanks again for joining late, everyone.
Oh, thank you, Kane. And I will let you get on with the rest of your day. Completely appreciated. And I'll share it on YouTube, everyone. I think I'm going to need to have a cup of chamomile tea now to stop my brain working before I go to sleep. I'll stop recording.
Great.
Brilliant. Thank you.
Thanks, Kane.